going to talk about the associative property and the multiplicative property and the communicative property. Lots of fun words here. Okay. So the associative property means I can rearrange. That's all that means. If I have A plus B plus C, does that also equal C plus B plus A? Or B plus C plus A? Or,
when I was doing this on Khan Academy, I wasn't doing too well. I didn't understand the commutative and the associative. They seem the same to me.
okay, we'll cover that. Okay,
So which one are you?
we're doing the associative property right now.
And all that means is that you can
Rearrange. I can rearrange. Okay.
in any order that you want.
In any order, as long as it's addition.
As long as it's addition. So is.
So let's say that these were all equal to numbers. Let's say it was 2 plus 3 plus 4. How can I rewrite that? 3 plus 4 plus 2. Or 3 plus 2 plus 4. Or I can get really tricky and go 3 plus 4 plus 2. Do those all mean the same thing? Okay.
You mind if I just, okay, so associative property only applies to addition.
Well, there's another one we'll talk about when we get to multiplication. Right now we're just doing addition. So this is addition.
So associative property says you can change the
I can
order.
rearrange. Yes, I can rearrange. So 4 plus 3 plus 2 is 9. So is it still 9 if I write it like this?
Mhm.
Okay, how about like this? How about like this? What about that set of brackets? Okay, so as long as it's just addition, I can rearrange it however I want. That's called the associative property of addition. Okay, multiplication. We also have an associative property of multiplication. So if I have A times B, are there other ways that I can write that to mean the same thing?
B times A?
B times A, okay, so I can rearrange. So that's what associative means. It means I can rearrange. So I can also write that as B times A. How else? What are some other ways we might see that written?
B parentheses A?
Okay. A parentheses B or B parentheses A. What about like this? Just AB. So the associative property means I can rearrange my terms. So if all I'm doing is adding or all I'm doing is multiplying, then I can rearrange them however I want. So let's say this was 3 times 4. What's my answer? 12. Okay, so it doesn't matter if I write it 3 times 4, 4 times 3, 3 times 4 in brackets, 4 times 3 in brackets, or 3 times 4 like that. They're all equal to 12. But where this comes into play is when I have expressions that I want to simplify. So on page 79, if you want to go to example 6 here, it says simplify these expressions. The first example is I have 3/8 minus 19 plus 5/8. Which are my two terms that are similar?
Fractions.
5/8 and 3/8. So I want to rearrange those. So I have 5/8 plus 3/8 minus 19. Is it easier to solve now?
3/8 minus 19 plus 5/8.
Mhm.
Okay.
So there's the tricky part. You have to keep the terms with their right symbol. The negative is associated here with the 19. So when I rewrite it, I need to keep the negative with my 19. This is a positive number, and this is a positive number. So I could also write it 3/8 plus 5/8. Right? Because of the associative property of addition, those are the same. So what is 5/8 plus 3/8?
8/8.
8/8, or 1. So this becomes simpler. 1 minus 19, negative 18. Okay, the next one they give us
So
is,
that's applying the associative property of addition.
that's applying the associative property. This one is in decimal format. So I have negative 2.5 times negative 1.2. So that's something else that we ought to address here. The little dot means multiply. It gets confusing if you're using an x for multiply, because what if I had an x here in my equation? So then I'd have 2xx. And so make sure you write multiply as a dot. So negative 2.5 times brackets, negative 1.2, exterior brackets, times 10. It's all multiplication, right? I don't have anything else. I have a multiply here and a multiply here. So can I rearrange? What about all those brackets in there?
Yeah, you can get rid of them all.
Okay, I can get rid of all the brackets. So I have negative 2.5 times negative 1.2 times 10. What do I want to do next? If I multiply these two terms together, what do I get?
1.2.
So I have negative 2.5
12.
times a negative 12.
So you did the tail end of the number first.
Uh-huh.
Why did you do
I didn't have to. I could do it either way. Now how about negative 2.5 times negative 12?
Positive 30.
Positive 30, right? 2 times 12 is 24. Half of 12 is 6. Add those together. Two negatives make a positive 30. So let's go back to this step and do it in a different order. See if we get the same number. Let's times these two terms together first. So grab your calculator. Negative 2.5 times negative 1.2.
How do you write a negative calculator?
Use the little negative sign down at the bottom.
Take the number first and then you do times 1.2. And you have to do the negatives.
Right, we had our double negative, right? One negative.
You know how many are total, so you know the
Right. So a negative times a negative will be a positive.
But now I know how to write negative.
Okay. So that's our associative property of multiplication. If all I'm doing is multiplying, then I can rearrange in whatever order I want, and I'll still get the same answer.
Do we need to know what associative property of whatever and commutative property of whatever means for the test, or do we just need to know that that's how it works?
Just need to know how they work.
Okay.
Yes. All right. Page 79, the additive and multiplicative identities. There's some more fun vocabulary. Additive and multiplicative. For any real number x, there is a real number negative x. So we have an x plus the 0 equals x. If I have an x plus a negative x, what does that equal? 0, right? So if I had 2 plus a negative 2, it equals 0. How about for multiplication? So there's our additive inverse, and we're going to do our multiplicative inverse. 1 times x equals 1x, or simplified x. So how do I turn that into a 0? What do I times x by to get a 0?
Negative.
0.
0. I can always times it by 0. X times 0 equals 0. What about 1 over x? We talked about using the reciprocal. What is the reciprocal?
X over
X over 1. So if I multiply that through, what do I get?
1.
1. I'll get x over x, which equals 1. So the additive inverse is whatever will get me to 0. The multiplicative inverse is whatever will get me to 1. So it's just the reciprocal again. Okay. So if I have 2 over 3, what's the reciprocal? Flip it over. 3 over 2. And that turns into 6 over 6, which equals 1. So the multiplicative inverse is kind of a fancy way of saying the reciprocal. So the example they give us here on page 80 is if I have an unknown number times negative 3/5 x equals 1 times x, or x. How do I figure out what this unknown number is? My x will carry over to here, so there's my 1x taken care of, but I need this to turn into a 1.
So we want the reciprocal of negative 3/5.
So what's the reciprocal of negative 3/5?
Negative 5/3.
Negative 5/3. And then negative 5/3 times negative 3/5 turns into 1.
You said the x carries over.
Well, the x, there's 1x here and 1x over there. So what I was trying to figure out is how to turn these numbers into a 1. So the second example they give is x plus 4.7 plus an unknown something equals x. So I have an x here and an x here. So the goal for this problem is to get this to equal 0. So what's the inverse? How do I get rid of that 4.7? What do I add to it? Negative 4.7. Okay, so there's the additive inverse. It's whatever will take this to 0. Okay, our next property, ready? Is the distributive property. The distributive property. I have A times B plus C. I need to distribute this and get rid of the brackets. How do I do it?
A times B
A times B
and A times C.
and an A times C. Does that distribute? I distribute this to get rid of the brackets.
When would you want to do that and why?
When we're solving algebraic expressions, we'll need to get rid of brackets, which means I'll distribute my numbers through.
And that's how you get rid of brackets? When you have a problem with that, you have to distribute?
You
get
have
rid
to
of the
distribute, so you have to multiply, because this really means A times what's inside the parentheses.
brackets? So to get rid of brackets, you can't just go B plus C and times it by A?
If you knew what B plus C was,
Yeah, so let's say,
but if you're dealing with any variables that you
Then
don't know what they
you
are,
don't always know
then
what
you
they
might
are.
have to distribute it through.
So how about example A here? 7 times P plus 5.2. I don't know what P is, so I can't solve this, but I can distribute the 7 through. So how do I do that?
7 times P,
Okay, it equals 7 times P.
7 times 5.2.
So what's 7 times 5.2?
38.5.
7.4.
Sorry. 35, 30.
36.4.
Yeah.
Okay, here's my sign. It's a positive. So that sign needs to also distribute. So I had 7p plus 7 times 5.2. So I can rewrite this 7 times p plus 36.4.
Now that's unsolvable at this point, right?
Unsolvable because I don't know what p is.
And if you had the equals, then we could figure it out.
Okay,
If
so
you
let's
know what the answer is, you could figure out P.
let's say p is equal to 3. How do I solve that?
3 times 7.
Okay, so replace my variable with some brackets. So 21 plus 36.4 equals
57.4.
57.4. The second example is negative 2.5 minus x. Okay, we talked about this a little bit before. If I just have a negative floating all by itself, what should I do?
Put a 1.
Put a 1 there. So it's really a negative 1. So if I distribute this through, what does it turn into?
And negative 2.5
Negative 2.5
plus x.
plus an x, right? Double negative there. So if x is equal to 4,
B 2.5.
plus 4,
Or, no, B
1.5. So the distributive property helps me to simplify things. So our third example is 7x cubed minus x cubed. Okay, now I want to undistribute, if that makes sense. Okay. So do I have two terms that are the same?
Kind of.
Kind of. I have an x cubed and an x cubed. So I can pull that out. I times x cubed by to go back to this?
7.
7. What would I time x cubed by to go back to this?
1.
1. Positive or negative?
Negative.
Negative. So x cubed, I undistributed the x cubed. I had that similar to both terms, so I can pull that out. So if I redistribute this, I would get 7x cubed minus x cubed. Now I want to solve for what's inside my parentheses, because it's 7 minus 1. So what's 7 minus 1?
6.
6. So I have x cubed times a 6. How can I rewrite that? 6x cubed. So that's the more simplified version of this formula. The fourth example is 5/2 n plus 1/2 n. So if I undistribute, I want to pull out the n. Okay. So I pull the n out. What do I multiply n by to go back to this?
5 2 or 5 over 2?
5 over 2. And what do I multiply the n by to go back to this? 1/2. Positive or negative?
Positive.
Positive. Okay, then solve inside my brackets.
6 seconds.
6 seconds, or
3.
3. So n inside. Now I need to use that associative property of multiplication here. Rewrite that. 3n.
Because it looks better, 3n looks better than n. 3.
The correct way is to put your coefficient first and your variable second.